To understand how this protection works, we need to talk about something called a hash. A hash is a unique digital fingerprint that represents all the information stored inside a specific block of transactions. This fingerprint is created using a mathematical process that takes the data inside the block and converts it into a fixed-length string of numbers and letters. Even though this string may look random, it is directly connected to the exact contents of the block that produced it. If someone tries to change even a very small detail inside the block, the hash changes completely. This makes it immediately obvious that the original data has been modified or tampered with in some way. Because each block is connected to the one before it using its hash, changing one block would also require changing the hash of every block that follows it. This would break the chain and alert the network that something is wrong. In order to successfully change past transactions, someone would need to update every single block after the one they modified, faster than the rest of the network is adding new blocks. This would require an enormous amount of computing power, which makes it practically impossible in real-world conditions. So at this point, we understand how transactions are stored inside blocks, and how hashes protect those blocks from being changed later. But we still have not answered the original question from the beginning of this video. If there is no bank involved in the system, who actually decides whether a new transaction is valid and whether it should be added to the blockchain? Instead of a bank, blockchain uses a network of thousands of computers that are connected to each other across the world. These computers are known as nodes, and they all work together to maintain and update the shared ledger by verifying transactions according to the rules of the system. Each of these computers checks transactions independently. They verify whether the sender has enough funds to make the payment, whether the transaction follows the network's rules, and whether it has been properly signed using the sender's digital key. This process does not rely on trust in any individual company or institution. Instead, every node follows the same set of predefined rules that determine whether a transaction is valid or not. Once a group of transactions has been verified, they are collected into a candidate block that can potentially be added to the blockchain. This block is then shared with the rest of the network for further verification. Other nodes in the network examine this proposed block to ensure that all transactions inside it are valid and that the block follows the network's rules. If most of the nodes agree that the block is correct, the network reaches a shared decision to accept it. This shared decision-making process between nodes is called consensus. It allows the blockchain to function without needing a central authority to approve transactions. Once consensus is reached, the approved block is added permanently to the blockchain. Because this process happens across many independent computers, everyone on the network ends up with the same updated version of the ledger. So instead of relying on a single institution to check whether your transaction is valid, blockchain distributes that responsibility across a network of independent computers. Each of these computers keeps its own copy of the ledger and continuously compares new transaction data with the existing records. If something does not match the rules of the system, the transaction is rejected before it can be added to the blockchain. Because this process happens across many different nodes at the same time, no single organization has control over which transactions are accepted or rejected. Every transaction must follow the same validation rules that are applied automatically by the network before it can be approved. These nodes are not making decisions based on trust or personal judgment. They are simply following the rules defined by the blockchain protocol. If a transaction meets those conditions, it can be approved. If it fails to meet them, it is rejected by the network. Since every node follows the same validation process, transactions are checked consistently across the entire network. This reduces the risk of errors or manipulation, because each node independently confirms that the transaction follows the protocol rules. Once a set of valid transactions has been verified, they are grouped into a candidate block that can potentially be added to the blockchain. This proposed block is then shared with the rest of the network for further verification. Other nodes in the network examine this proposed block to ensure that all transactions inside it are valid and that the block follows the network's rules. Once enough nodes agree that the block is valid, it is added permanently to the blockchain. This creates a shared version of the transaction history that is updated across the entire network. After a block is added, changing the data inside it becomes extremely difficult, because doing so would affect every block that follows it in the chain. Blockchain networks are also permissionless, which means anyone can participate in verifying transactions by following the protocol rules. So when you send cryptocurrency, your transaction is not verified by a bank or any central authority. Instead, it is verified collectively by a distributed network of computers.